Okay, in this question we are given dy dx equals to 4x cubed minus 12x squared. So we want to find the curve, we need to integrate dy over dx. This gives us y equals to 4, x to the power 4 over 4 minus 12x cubed over 3 plus a constant c. So to find the value of this constant c, we need to substitute the coordinate in, because this passes through the curve, which is x equals to 0 and y equals to 27. This is the coordinate of that point. And when we substitute in, we find that c is actually equals to 27. In other words, the constant has a value of 27, and therefore the curve y is equals to x to the power 4 minus 4x cubed plus 27. But the next part, we want to find when dy dx is when the curve is an increasing function, that implies that dy dx has to be bigger than 0. So by writing out the equation again, 4x cubed minus 12x squared is to be bigger than 0. So 4x squared times x minus 3 bracket is bigger than 0. From this inequality, we see that x actually has to be bigger than 3 for the increasing function to hold. The next part, the stationary point implies that dy dx equals to 0. So we do the same thing, we change dy dx equals to 0 and solve for x. We get x equals to 0 or x equals to 3. So when x equals to 3, y will be equals to 0. So that is one stationary point. However, when x equals to 0, y equals to 27, and that's another stationary point. So altogether there are two stationary points. Finally, we want to find the nature of these two stationary points. So we find the second derivative, which is d squared y over dx squared. We get 12x squared minus 24x. So let's go back to the first stationary point again. At 3, 0, d squared y over dx squared will be 12 times 3 squared minus 24 times 3, which is equals to 36, and that is bigger than 0. And when d squared over dx squared is bigger than 0, the second derivative, it implies a minimum point. As for the next stationary point, where at x equals to 0 and y equals to 27, the second derivative, d squared over dx squared, gives us a value of 0. So we are unable to tell what is the nature of that point, so we need to use the sign test. So we use the value of x equals to 0. So if it tends to negative, dy dx is bigger than 0. However, when it tends to positive, dy dx is less than 0. And from these two evidence, we find that it is actually a maximum point, because it goes to a maximum point and comes back down again. So at 0, 27, it is a maximum point. Thank you.